Algebra 1 students, here are your 6.2 notes. We've looked at one method for solving systems of equations. We have a couple left. The first of those is the one we'll look at today, and that is solving systems with substitution. The substitution method, it's effective. It always works when you use it, and it's a pretty straightforward way. In other words, you follow the same process every time, and you can use it again to solve the systems. Three simple steps. The first one is you have to pick one equation and solve for one of the variables, either x or y or whatever variables happen to be connected to that problem. Then you take that value and you plug it into the other equation, and then you'll solve for the missing variable by using that second equation. So let's take a look at a pretty simple example of this. Here we have a system that says y equals 4 and 2x plus y equals 12. The key to this is right here, y equals 4. I'm going to plug that value in right there for y. So I'm going to rewrite the second equation, 2x plus, and instead of y, I substitute and write the number 4 because we know that y and 4 are equivalent. Now I can subtract 4 from each side, so 2x then would equal 8. And a quick step of division tells us that x is 4. Now I'm going to go ahead and write the solution as an ordered pair. We know the x value is 4. The y value was given to us right at the beginning, and it's also 4. Now if you think about this in terms of our previous method, that means that these two lines intersect at the point 4 and 4. You don't have to graph it to see that, but it's just showing you that these two methods, even though they're different, they get you the same result. All right, let's take a look at this. Number 1 says solve the system by using substitution. Now again, it's laid out pretty nicely for us where we know a value for y is 3x. So I'm going to take that and plug it in right there for y. So 2x minus 3y, but instead of y, I put in 3x equals 28. So everything stays the same other than changing y to a 3x. So here we go, 2x minus 9x is equal to 28. Combine like terms and divide, and we know x equals negative 4. Then the last step is just to take that x value. I'm going to plug it into the first equation. You could plug it into the second. I just think the first one is a little bit simpler equation. And I have my solution. It's negative 4, negative 12. Again, that means if I graphed those two lines, they would intersect at the point negative 4, negative 12. Okay, now in number 2, you'll notice that we don't have something laid out quite as simply for us. We'll have to do a little bit more thinking on how we want to approach this one. Now I notice this. On the first equation, I have a 2 and a 2x and a 5y. I could solve for x or y. That would work and it would be fine. However, on the second equation, I just have a 1x and a 1y. So to me, it makes sense to solve for either x or y. I'm going to go with x just by simply adding y to both sides. I know that x equals y plus 4. Then I can go to that first equation and plug it in for x. So instead of 2x, it's 2 times y plus 4 minus 5y is 19, so I can distribute. So let's see, 8 minus 3y equals 19. If I subtract 8, so y then is negative 11 thirds. Now this one's just a little bit uglier when I need to solve for x because I got that fractional value, but it's okay. I'm going to use the second equation again because, well, basically because I think it's a simpler equation. And I'm going to substitute. Instead of writing x minus y, I'm writing x minus 11 thirds. So this value from here goes to there instead of y. All right, So this says x plus 11 thirds equals 4. Now, if you want to make your life a little easier, think about 4 as being 12 thirds, because when we subtract 11 thirds, you'll get an x value of positive 1/3. So our solution is 1/3, comma, negative 11 thirds. That's the ordered pair. Some of you may be saying, how do I know if this answer is right? Like, what is it about this that tells me it's right? There are a few ways you could check that. One would be to graph. I don't like that idea because that's basically redoing the whole problem. But you do have the option of plugging these values in. Now, my advice, since we used the second equation to find x, check your answers with the first equation. So pause the video now and check your work and see if it makes sense to plug these two values, 1/3 and negative 11 thirds, into the first equation. Now hopefully you checked your answer on this. Basically what we'd be looking at is we'd have 2 times 1/3, which is 2/3, minus negative, so I'm going to just change that to a plus, 5 times 11 thirds, so that's 55 thirds, equals 19. And we're saying, is that true? Well, 57 thirds is exactly 19, so that is true, and that confirms that our answer is indeed correct. All right, continuing on. Solve the system using substitution. Now, number 3, I know you guys all love fractions, so I made sure to include that for you. But I was nice to say, look, right there, there's a y. We can substitute right there. So I'm going to rewrite my second equation. And all that I'm changing is, instead of writing y, I'm writing 4/3 x minus 6. Now we need to do a little distribution. Now this is kind of interesting. 0 minus 18, so that's negative 18, equals 6. What's going on there? What's going on here is that we have no solution. Now, how is it that we get no solution to a system of equations? I want you guys to answer that question. Why is it that there's no solution? Write the answer on your notes. Okay, let's look at number 4. Similar question to all the others that we've seen. Now, again, we're going to use substitution. What I'm going to do is take a look at the second equation, and I'm going to divide everything by 3. And my new equation will look like this: y equals 4 minus 2x. I'm doing that so that, again, I can plug that value right in there. So instead of y, I'm going to have 4 minus 2x. So 10x plus 5, replace the value for y, still equals 20. Let's see what happens here. 10x plus 20 minus 10x equals 20. 20 equals 20. The 10x's cancel. If you subtract 20 from each side, you'll get 0 equals 0. What's going on here? Well, infinite solutions. We've seen this before when we solve systems, but my question to you is why? How do we get infinite solutions when we're trying to solve a system of 2 equations, or you could think of it as 2 lines? How does that happen? Again, write your answer down. All right, let's take a look at the last, is this the last? Excuse me, the second to last problem. A group of 15 friends decide to attend a Sporting KC game. Good choice. Tickets in the members stand are $30, and the South stand they're $35. There weren't enough tickets in either section for the group to get to sit together, so they split up, and they spent $480. How many sat in each section? So in this case, we're going to have to come up with our equations. First thing I'm going to do is define variables. I'm going to say that x represents the number of members club. and I'll abbreviate a little bit, we'll call that MC, where Y is going to represent the number of South Stand. And this references the number of South Stand tickets that are purchased, which also could be considered to be the number of people that sit in that section. All right, so let's write this system. That means write our equations. Well, the first thing I know is that we have 15 people, so we're doing X plus Y has to equal 15. Number of South Stand people plus the number of Members Club people has to add to 15. The other equation is going to deal with cost. Those Members Stand tickets cost $30, where the South Stand tickets cost $35. So I'm going to do 30 times the number of Members Club tickets plus 35 times the number of South Stand equals $480. That's your equation that deals with cost. The first one just deals with number of people. Now, because that first one is the simpler equation, I'm going to go ahead and use that one to solve, to begin my substitution, I should say. So y then is 15 minus x. I'll rewrite the second equation, 30x plus 35 times 15 minus x equals 480. So here we go, 30x plus 35 times 15. You may need to use your machines to do this, but 35 times 15 is 525 minus 35x is equal to 480. All right, let's combine like terms. So negative 5x plus 525 equals 480. We subtract negative 5x equals negative 45, and then divide. We know that x is 9. Now I'm going to go up to that simpler equation and do 9 plus y equals 15. So I know y equals 6. Now I can't just write the answer as an ordered pair. This is an application problem. So we need to know that we have 9 tickets to the Members Club, and 6 to the South Stand. Not the best sentence, but it gets the point across. All right, the last one finally. The measure of one acute angle in a right triangle is 36 degrees more than twice as big as the measure of the other acute angle. Define variables, write the system, and solve to find the measure of the two acute angles. And a reminder here that the three angles in the triangle sum to 180. I could even be more specific. The two acute angles would sum to 90 degrees. I'm going to keep that in mind. All right, so I'm going to say x is one angle, and y is the other angle. All right, let's set up our system of equations. The sum, as I mentioned above, has to be 90. Now the other one we have to do a little thinking. It says the measure of one acute angle is 36 degrees more than twice as big. So what I'm going to do is say I'm going to assume that y is the bigger of the two. And if it's twice as big as angle x plus 36, my system would look like this. Pause the video, solve the system on your own, and see what you come up with. Okay, you guys can see the work I've done. I substituted in a y value, used that to solve for x, and then substituted back to solve for y. That gave me the two angle measures of 18 degrees and 72 degrees. Come to class ready to work tomorrow. We'll see you guys.